All right, guys, I got this Schauer 4 Seasons fully automatic solid state battery charger. I've never seen it working, but I would like to get it working. So right now, it doesn't work. All right, so see my voltmeter here. I'm gonna put this on the clamps, black on black, red on red. You can see I get nothing or next to nothing. It just flickers a teeny bit, but there's not much there. It is plugged in right now. If you look very closely, you can see this is burned out right here. Now this whole setup is this little precision control. Okay, I don't understand how that works. I'm assuming if you're going to have this maintain a battery for you without being monitored, I'm assuming you set that to either be a slightly higher voltage or slightly lower voltage or amperage, one or the other, so you don't cook your battery, but so that you do maintain it effectively. I'm okay bypassing that if we need to, because I don't know what to do with this. The plating on the back is burned out as well, and I don't know where to get these conveniently. So I'm gonna try to bypass this. So without further ado, let's show you what I got here. Okay, so like I said, it is plugged in right now. I have it set on the DC setting. Let's see where we do have voltage. All right, so I checked the AC. I do have AC current coming into the transformer, so that's good. All right, I did that by turning this to the AC setting. Now, let's see, coming out of the transformer, got 3 legs. I don't think, so my first inclination would be that one of these would be positive, one would be negative, so what's the third? I don't know, but that's not how transformers work. This top one and this bottom one both feed to this heat sink with diodes. Something about rectifying or rectification or bridge rectifier, I don't understand it all, but current is flowing in through here. I think it's probably both positive current, if that's how I can say it. And then as it alternates, something is lost inside the heatsink, and then by the time it comes out the other side, one's positive, one's negative. I don't fully understand it, but bear with me. So if I take my positive and go to the transformer, and then take my negative, let's start over here. I got nothing. Really nothing. But then if I come down here to this little one, I can't see it. Stay with me. So I come down here, 3.3 volts, don't know what that's all about. 3.5 volts, not sure what that's about. But if I go to this red one, there's my 13.9 that I'd be looking for if I wanted to charge a battery. Now I'm going to go back to the red one on the transformer. I'm going to step it down to the second one down, 13.6, and I'm still on the red one down here at the bottom of the heatsink with the negative. Now I'm going to go take this to the third step down on the transformer. I'm still in the same place with the black one, and I got 13.9 again. All right, so again, these are nothing here until it comes out of the heatsink, and then we have a positive and negative. So let me go down here again. I'm gonna take my red to the red at the bottom of the heatsink. Let me go over this little diode here with the 2 little black legs. Let's see what we have. 13.59, 13.6. And go to the other leg, again 13.6. So if I didn't know better, I'd say this red line here could be my positive, and either one of these black lines could be my negative. Let's see if that hypothetically works. So where do these black ones come from? Where do they go? So if we follow this one, it's gonna go up to here on the back of my amp meter. From there it goes up to here. It's the third leg here. All right, so theoretically, if I take my positive again to the bottom of this red one here, this will have a point, I promise, and then I go up to this third leg. Yes, I would see my voltage. So I wonder if there's a way to reroute. Let's see if I'll do this too. Yeah, so I thought. So if I'm at the red here with my red and I'm on the black with the black, it's the same, 13.6. So I wonder if there's a way to reroute these two, this red and this black, to be my positive negative, and totally eliminate the use of this little chip, this board here. The reason why I'm considering eliminating the PC board here is because the energy is flowing into it, but not out of it, because it is burned up. All right, so let's go back here now. So this, I believe this is my positive. Yes, this is my positive line. And right now this is going down to this precision control unit. That is tied into this precision control unit up here, the chip, the board. So I'm probably going to eliminate that as well. We'll see. I'd love to keep the amp meter, have that be a functioning part of this. So looks like my negative goes to the amp meter, and the negative comes out of there and goes over here. So we're going to unplug this. Okay, so now that's not going to the board. This has power though. We'll call it negative power. All right, this is my positive. This goes, let's see, to here. How do I get how do I follow the red one back? Let me just unplug the red here. Okay. Let's do a test on just these two pieces without shorting anything out here. I'm gonna stick the black into here, this little plastic coverlet. Come back live, voltmeter, please. And we're gonna go to the red, just make sure everything's still alive like we expect it to be. It's not. How come? How come it's not alive? Why wouldn't it be alive? Has something to do with this board or one of these other wires? What's going on? Okay. So let's put this red one back then. I guess maybe this black is being fed by another one of the blacks. So let's back up here. So maybe, hold on, let's take the red and we'll engage the voltmeter with that. And then, okay, so that has power. So this black is being fed by something else. So this black comes down here. And then from there it goes down to this leg of the diode. Okay, and why doesn't it have power though? If I unplug this, this is now powerless, right? Yes, but how about this one? This one still has power, so maybe that's the supply. Let's see. Let's see. Get my red in here. Yes, okay, so that's my supply. Let's put this one back in here so I don't forget where everything goes, just in case. Okay, so this is my positive, this is my negative. Now, how to get these to go where I want them to. All right, first, I'm gonna get rid of this zip tie here. It's not helping us anymore to my knowledge, as far as I can tell. You should be dry rotted by now. You must be 20 years old. Don't cut my wires. Don't make sparks. Okay, zip tie is off. Okay, these are the two wires we have. So this one's got power, and this one has power. So let's see. So why does this one have power? Well, this one comes directly from here. Can you see where I'm pointing? On the precision unit. So this black wire that is live, I follow that down. That goes to the precision unit down here. And that precision unit on the middle, which is where this wire is coming from, is directly connected to the one on the inside. So that one is gonna go right to the middle foot of the transformer right here. Hope you can see that. I know there's a lot going on here. Okay, so that's why it's live. So we have the top leg and the bottom leg of the transformer feeding the heat shield, the heat sink, and then we have positive power coming out of the heat sink in the red. Then we have the middle leg of the transformer feeding the precision box here, and this comes off that precision box. Now we've cut out the amp meter, so that's not what I really want to do. So maybe we can, here's what we're gonna do. Okay, so you're only watching this if you're crazy. You're only watching it still if you're crazy. So we're gonna take this and we're gonna repurpose these wires. All right. Okay, let's keep those two away from each other. Far away from each other. Okay. Let's repurpose these wires. So this goes down to here. We're gonna take that off if we can. We can. All right, and they're stuck together because one of those is a double. I feel like I should probably unplug this at this point because we know what direction we're headed in. We're still figuring out how to get there, so we want to shock ourselves here. Okay, let's disconnect these. We don't need them to be stuck together. Okay, got it off. Okay, so these two are the live ones. So what if we come off of that precision box now and go to the amp meter? And that way, if I go, if you have enough light here. So this is my live black wire. Right here, goes down to the precision box. So if I take this out and put in one that has a bigger spade head, I can go from the precision box, which is being fed power from the transformer, and I don't have to go direct to my negative. I can go through the amp meter right here, because this is already connected here to the negative, I think. Or is that positive? Let's see which one of these wires is which. Which one of these wires is which? I wonder if one of these has knurlings. So my smooth wire is my positive. My black negative wire is my knurled one. So it looks like Mr. I can't tell in the box. They both look kind of gnarly. Two negatives, negatives. So this would be negative right here. Negative goes to the precision box. That's not what we want. Okay, well then. Well then. Okay. Okay, I think we could just yank this wire. rid of it. Eliminate the precision box. We're just going to use the one side of it that has the 2 metal prongs. We're not utilizing the precision box. We're just landing on it. So we're going to pull out this negative wire right here. Fairly positive that's negative. Haha. And we're going to move it over to this one right here. So we're using the precision box only to land on it to get the power we need, but we're not actually utilizing the precision box for a precision box. So we can get that to lift off there. Sometimes I use a small screwdriver and lift up on these spade terminals to get them off. Oopsie daisy. Huh. Well, let's see what's in it at least. Is that it? Just like a flexible thing. So I'm assuming it's either magnetic or heat related, and when it gets hot, it pops off and stops charging. And when it cools enough. Interesting. But we're not using it. So let's take it off. And we're back. Okay, so we're just using this control board or this precision board now to get power to negative. So if this is my positive power, which I think it is, we're just gonna add a bigger spade to it. So it's full size as opposed to this. It's like the one I'm putting on is F2. The one I take off is smaller than an F1. It's like an F half if that exists. I don't know. So this ready. Oh, let's see if my smaller one. Whoop, there goes the smaller one. All right. Smaller one might fit. Why are we doing this? Why, guys? Why? Well, I really like the manual jump boxes or the manual chargers. I know it says this one's fully automatic, but by the time we're done with this, we'll have ruled out the automation and it'll just be capable of charging pretty much non-stop, which I know has its downsides, but also has its upsides, because a lot of times I had a friend tell me once, some companies are making battery chargers to increase their sales of batteries. And what he meant was that, you know, they have that feature that says bad battery, bad bat, you know, and maybe your battery's fine, is what I'm getting at. Maybe the charger just didn't know how to charge it. You know, why do we throw things away? Because we don't know how to fix it. Maybe that's what's going on with this charger. Who knows? So, just a guess. So I like the manual ones, the ones with transformers, because I think that they are more reliable. Maybe you need to babysit them more so they don't burn anything up, but I really think they're more reliable as far as actually getting your battery to charge. So I'm gonna stop talking, so I am thinking. I'm gonna plug it in. Hopefully nothing explodes over here. Okay, good. All right, so let's go back to here. So we're saying this down here on the precision board, connecting up here to this red, we have 13.34 volts. Good. Now, if I have this one and then this other one, got nothing. Wonder why. I don't know, but I'm okay with that. Okay. Okay, so now what I think we're gonna do is I think we're gonna hook this up to my amp meter. Okay, I'm not getting sparks because it's got power running through it, but it's not going anywhere. The clamps aren't hooked up to anything. You know, the clamps where you can see them. Positive, negative. All right, let's do a quick voltmeter test. I don't think this is going to have anything that's wires dead end. So look, 0 volts on the voltmeter. Oh, can't really see that. 0 volts in the voltmeter. Now we're going to hook this up to my amp meter, which is connected here to the positive. So we got positive power running through the ammeter to tell us how many amps are going through the ammeter into the battery ultimately. And that's how ammeters work. They measure the current going through it. So hook that up. Now we should have power at our clamps, assuming our wires are sound. And positive, negative. Yes. So now this is an automatic, this is a manual charger, and you are not supposed to do this, but I'm going to do this as a test. All right. So this is now a solid state, fully manual battery charger. What do we do with this wire? I have no idea. Will we need it later? The chances of me coming back and doing any other repairs now that I've torn this apart are extremely slim. Partly because I'm not going to remember except with this video where things went, and partly because it's working, and I'm okay with that. And I'm okay leaving it at that. So I am going to cover up this loose end with some shrink wrap. I like to seal my loose ends with a pinch. That way they're actually sealed there. Now we are going to close this up, and yeah, that's it. So I guess looking at it now, this diode on the bottom, I don't know what it's supposed to do. If you do, feel free to leave me a comment and try to educate me through the text of a comment. I know that's hard to do. Or post your own video and link it to the comments, telling me what this is supposed to do. Because right now, this I just blocked off with the heat tape, and then the other leg of it, goes up to here, and that's not connected to anything. So that diode is essentially doing nothing, as far as I'm concerned. I don't know. Maybe that's supposed to prevent power from backfeeding from the battery and frying something in here. Diodes, they're one way. They stop power from going to places they shouldn't, so maybe that's what it is. I don't know. So I guess at this point, yeah, I just don't know. Don't know. Okay, well, we're gonna seal it up. All right, we're gonna plug in our battery here. Battery has a voltage of 12.82 volts. We're gonna take our now manual charger and hook it up. Zap like a manual charger does. Now we're getting 15 volts, so this thing is charging with a fury. Cool. And that'll taper off and calm down as this battery tops off the rest of the way. So there we go. We were able to take this fully automatic battery charger and turn it into a fully manual battery charger. And I'd rather have one of those anyway, so yeah, I'm happy with how this turned out. I'll be keeping an eye on these batteries that I charge using this charger, just to make sure there's no incidences. Obviously charging anything can be a fire hazard, so you always want to keep an eye on things. Automatic chargers, there's less of a chance of that happening, but still, you got to be careful. So if you don't have a charger you trust, don't leave it unattended, and don't do it in a small enclosed space like your garage or your house, so basement or something. This is not a charger I trust, so I will be monitoring it until it gains my trust. So guys, thanks for watching. Hope you found this interesting. If you watched to the end of this video, you must be crazy like me, so thank you. If you made it to the end of this video, why don't you leave me a comment, and in your comments somewhere say 4 Seasons battery chargers are overrated, and I'll know you watched to the end. All right, guys, till the next video. See you later. Thanks.